Computer Literacy Unlocked, Episode 1: The Skill Nobody Taught You. Chapter 1: What is a computer, really? Welcome to Computer Literacy Unlocked, the podcast where we give you the education the system forgot to deliver. I'm Dr. Jean Constant, founder of Global Sovereign University, and I've spent my career watching brilliant people get left behind, not because they lack intelligence, but because nobody took the time to teach them properly. That ends today. I want to start with a question. If I asked you right now, what is a computer, really? Could you answer me? Not what it does, not how to click through it, what it actually is. Most people can't. And I don't say that to embarrass anyone. I say it because that gap, that missing foundation, is precisely why so many capable adults feel helpless in front of a machine that is, at its core, remarkably logical. Here is the whole thing in one sentence. A computer is a machine that takes input, processes it, and produces output. That's it. Input, process, output, IPO. Every single thing a computer does, every email, every spreadsheet, every video game, every artificial intelligence application follows this model. You type on a keyboard, that's input. The processor calculates, that's process. Words appear on your screen, that's output. Once you understand IPO, you understand computers fundamentally. What is inside the machine? Now let's open the machine and look inside. Don't worry, I'm not going to ask you to pick up a screwdriver. We're going on a conceptual tour. The first and most important component is the CPU, the central processing unit. This is the brain of your computer. Right now, as I speak, the CPU in whatever device you're using is executing billions of instructions per second. Billions. Every program you run, every calculation, every action you take, the CPU is the engine powering all of it. When you hear people talk about processor speed, 3.5 gigahertz, they're talking about how many cycles per second the CPU can complete. More cycles means faster processing. The second component is RAM, random access memory. Here's the analogy that makes this click for everyone. Your desk at work. Your desk is RAM. It's where you keep the things you're actively working on right now, the project you're reviewing, the pen in your hand, the coffee you're drinking. RAM is fast to access because it's right in front of you. But here's the key. When you leave the office at the end of the day, you clear your desk. RAM works the same way. When you turn off your computer, everything in RAM disappears. That is why saving your work matters. If you don't save it, write it to permanent storage, it is gone when the power goes. Which brings me to the third component, storage. Your hard drive or solid-state drive, HDD or SSD. This is your filing cabinet, permanent storage. Everything on your computer that persists, your operating system, your applications, your documents, your photos, your emails, lives here. Unlike RAM, it does not disappear when the power goes off. The main difference between traditional hard drives and the newer solid-state drives is speed and durability. SSDs have no moving parts. They're faster, quieter, and more resistant to damage if you drop your laptop. Hard drives have spinning platters inside. They're slower and more fragile, but they hold more data for less money. You don't need to know which one you have to use your computer effectively, but knowing the difference explains why newer computers feel so much faster than older ones. Fourth, the GPU, the graphics processing unit. While the CPU is the general-purpose brain, the GPU is a specialist. It is purpose-built for processing visual information, the images on your screen, the video you are watching, the graphics in a game. If you have a smooth, beautiful display experience, thank your GPU. Most ordinary laptops have graphics built directly into the CPU chip. Dedicated GPUs, separate cards, are what you find in gaming computers and workstations used for video editing or three-dimensional design. And fifth, the motherboard. This is the least glamorous component and the most fundamental. The motherboard is the highway system. It is the main circuit board that physically connects everything else. The CPU, the RAM, the storage, the GPU, and the ports you plug things into. Without the motherboard, you have a collection of components that cannot talk to each other. With it, you have a computer. Software, the instructions. Hardware is the physical stuff, the chips, the circuits, and the components we just covered. Software is the instructions, the programs, the code that tells the hardware what to do. There are two categories of software. The first is the operating system, Windows, macOS, Linux, Android, or iOS. The operating system is the master manager. It coordinates all the hardware, runs all the other software, and provides the interface you actually see and interact with. We will spend an entire episode on operating systems, but for now, just know the operating system is what makes your hardware usable. The second category is applications, or apps, word processors, web browsers, email clients, games, and spreadsheet programs. Applications run on top of the operating system, and the operating system manages them. Here's the analogy I use. The operating system is the stage. The applications are the performers. Why this matters. Dr. Constant. I know what some of you are thinking. Gene, I don't need to know what's inside my car engine to drive to work. Why do I need to know what's inside my computer to use it? Here is my answer. You don't need this knowledge to click through menus. You need it to stop being intimidated. When your computer slows down, you now know why. Probably too many programs fighting for RAM or thermal throttling because the processor got too hot. When someone tells you that a computer has an i7 processor with 16 gigabytes of RAM and a 512 gigabyte SSD, you now know exactly what that means. Fast brain, good desk space, adequate filing cabinet. When a salesperson tries to convince you to spend $1,000 more for features you don't need, you can evaluate that claim intelligently. And most importantly, when technology changes, and it will always change, you have the foundation to understand the new thing. Because all of it, no matter how sophisticated, still follows input process output. The fundamentals do not change. That's our first episode, the foundation, the machine demystified. In our next episode, we are going to zoom out and look at something even bigger, the internet. Where does it actually live? What happens when you type an address into your browser? Why does your page load quickly sometimes and slowly other times? The answers are more interesting than you think. Before you go, head over to globalsovereignuniversity.org and play Computer Autopsy, the free book game that goes with this chapter. You will get 20 questions, bronze through platinum difficulty, and Gino, our AI tutor, will coach you through anything you miss. The game is free. Gino speaks 32 languages, and the book this podcast accompanies, Computer Literacy Unlocked, is completely free at our website. This is Computer Literacy Unlocked, and I will see you in the next episode.